So John, welcome.
Well, good morning everyone. This is going to be a bit different from what you've heard because I'm going to talk about seaweeds. I'm going to talk about things mostly from a global perspective, at least initially, and then this is the one down there. So a global perspective initially, and then I'll look at some things that might be applicable locally later. And much of the emphasis is going to be on the production of food rather than worrying too much about carbon sequestration. The philosophy being that if we can actually accomplish two things at once, it's more likely that we'll try and accomplish them at all. So that's the first slide which I'm showing here is just a picture of some Chinese fish algal farming. The Chinese produce something more than half the world's farmed seaweed right now, about 10 million metric tons a year, and that's then just harvesting kelp there.
Can you use the microphone, please?
Yeah, sure. So this slide just shows you some seaweed products. I guess most people really don't think too much about seaweeds during their average day, but in practice they play a relatively low-key role in most of our daily lives. People, I guess, these days are familiar mostly with sushi, but their seaweed products and byproducts are in a lot of normal domestic products like toothpaste and even beer as thickeners and gelling agents. We eat them as health foods. Agar plates, anyone who's done bacteriology is very familiar with those. They're in soaps and cosmetics. And you can buy seaweed fertilizer in the garden store. And more we're seeing, I think, on menus around the country, seaweeds being used in salads and so forth. And I see that as a trend that is likely to continue. If we go back 100 years, there was a very substantial seaweed harvesting industry up and down this west coast here. It was in 1914, at the beginning of the First World War, people realized that we imported all our phosphate at that stage or potash I should say, from Germany. That wasn't a good thing to do at the start of the war. And we needed acetone, which was a chemical used in the process of making cordite, which is a smokeless gunpowder, which was being used then. So 11 of these factories, that you shown here in the top left-hand corner, were established up and down the coast to process harvested seaweed off the west coast here, the macrocystis. And you can see from the graph how the harvesting peaked during that time. It dropped to zero, and then it has sort of increased a little bit since through the rest of the century, and much of that's being harvested to produce alginate, which is one of the gels and thickeners that you can produce from seaweed, which I mentioned. If we come forward a little bit further to the late 60s, there were two American scientists, Wheeler North and Howard Wilcox, who came up with this concept of what they called ocean food and energy farms. And they proposed this, and then it was in 1973, I think it was, that the first world oil crisis happened. Some of you will remember that. There were all kinds of political problems in the Middle East. OPEC started to flex its muscles, the price of gas went up, and everyone got worried about it. And the Department of Energy at that time decided, well, they would try and look at seaweeds as a potential source of biofuel, as an alternative source of energy. And they put a lot of money in over about 8 years into a program of research to look at large-scale production of seaweeds off the west coast here for the production of biofuel mostly and to a lesser extent food. Now, that program finally came to an end for several reasons. The main one really is that the oil crisis came to an end, but also because when I was looking at these things, biofuel is really the wrong end of the value chain to start some of these things. It's the low value end. You need a huge quantity of biomass, you need to produce at a low cost, and if you're starting to farm something, as in this case the seaweeds, that was, as I say, not something you could be certain of. And at the same time, they didn't really pay much attention to the value of byproducts. Nothing else one needs to try and maximise the value from the whole raw material. And also, I think probably at that stage there was insufficient appreciation of need. And this country is rich, but mostly well fed. The idea of going to the sea to produce more food is not something that is probably was then a high national priority. Not sure that things are so simple these days. Here we are in 2014, and the world has some new and interesting challenges. How to feed it as we go forward is one of the things that people are asking about. In the time since the 80s, the population of the world has increased by 2.5 billion people. It's going up at a rate of about 219,000 people every day. Increasing affluence in countries, particularly China, is leading to increased consumption of food, particularly increased consumption of meat products. Climate change is threatening agriculture in a number of different parts of the world, as is water shortage, both pumped and rainfall. We've got a problem in Southern California right now, as you will know. And FAO is telling us that they think we will need another 5 billion metric tons of food to feed us all by the year 2050. And if we look at the oceans, although we're sort of preoccupied with them here and we talk a lot about them, they actually don't produce very much of our food. The world produces about 7.5 billion metric tons of food every year. Our commercial fisheries worldwide produce about 80 million tons. Aquaculture, in marine aquaculture I should say, produces about 38 million tons. About half of that is actually seaweed, for a total of 118 million, or about 1.6% of our total food supply. And I guess the question I've been asking, and the proposition really, is, well, if we really do have a global food crisis threatening, does that make sense? Should we be thinking about trying to do something about it? And there's no great secret as to why it happens. If you look at the makeup of our present world food supply, most of it's plant material. In fact, it's all based on plant material to start with. It's all based on basically photosynthesis, producing proteins, lipids, and carbohydrates that we want, which we can eat or we can feed to animals. And the vast majority of them, on a global basis, are eaten by people. About 85% of our diet is plants. 15%, the other 15%, much of that is dairy products, much of it milk, so much of that's water. And you actually get just the meat and fisheries, aquaculture, animal products. It's really very small quantities in terms of our total consumption. And so the question is, or the proposition is, and I've been trying to argue through, is can we turn to the sea? Can we look at the oceans as a basis for a photosynthetic system of food production in the same way as we've developed on land? What some of us have called a marine agronomy, and there's a little website there referred to as marineagronomy.org, where you actually find some quite interesting, good information about this as a concept. Now, if we look at the oceans and the photosynthetic capacity of the oceans, the vast majority of what happens in photosynthesis at sea is in the production of phytoplankton. The tiny little plants that form the basis of the food chain. 97% of ocean photosynthetic activity is phytoplankton. We can't do much with that. We can't harvest it because they're too small and they're too scattered and we can't filter it. So we rely on the marine food chain to do it for us. And the problem with that is that the marine food chain is actually not that efficient, because you've got to go through several trophic levels before you get to fish that we can actually catch and eat. Each trophic level you only retain about 10% of the energy, the food that was originally eaten. And if you take an average trophic level for our fish, which is 3.1, which is the number which is often used, you can calculate that 80 million tons of fish that we catch in our commercial fisheries every year comes originally from 10 billion metric tons of phytoplankton. And the ocean's equivalent to the terrestrial plants we farm are the macroalgae. They're not plants, they are macroalgae. There's a distinction that botanists and biologists make. But they operate like plants, they photosynthesize. We've heard a lot about photosynthesis this morning. They take simple things, sunlight, nutrients, carbon dioxide and water, and turn them into things that are useful to us, proteins, carbohydrates and fats. as well. And they only represent 3% or so of the total ocean's photosynthetic activity. And the reason for that is that they need access to light. Most of them need access to some sort of substrate on which they can attach so they can reach the light. So they're restricted to our coastal waters where they can attach to something and then get up there. There are also a few floating species. I'll show you a photograph of one of those in a minute or two. But if we're going to do something about that, if we're going to intervene, if you like, go into the marine environment and say, well, we're going to increase the photosynthetic capacity by growing macroalgae, we need to put structures in the water to which these things can attach and grow. And I've illustrated this with a couple of photographs here from Maine, actually, and I'll talk a little bit more about this company in a minute. Where you see on the left there a photograph of just a rope. It's not just a rope, actually, that's got little baby seedling brown algae on it, Saccharina latissima algae, and you can see the same rope a few months later after it's all grown and the algae are ready to harvest. So, if that's the proposition, if the idea is that in principle it might be a good idea to try and put structures in the sea to produce more biomass, to provide some of the food and other materials we need, in the process to use some of the carbon dioxide that's causing us problems with ocean acidification. The question is, what are the pros and cons of that? Because there's always cons, and these are some of the pluses and minuses. First off, self-evidently, if we're going to do something like this, we don't need land or fresh water. And those are limiting resources in terms of our agriculture. And as we've heard today already, by doing this we will improve water quality. Not only removing CO2, but removing nutrients too. Some seaweed species grow very fast, so one can actually sort of get a lot of activity going in quite a short space of time. Macrocystis, the one we have off the west coast, happens to be one of those. People will say that it's the fastest growing plant on Earth. I'm always a bit sceptical about those sorts of claims, but certainly it makes the point that it grows very fast. They don't contain any lignin, which is a double-sided benefit really, because on the one hand it means that all the material is useful in terms of processing into things we want. On the other hand, there's no refractory material like you have in wood, which was referred to after. There's nothing which will actually fix carbon permanently. It's all relatively usable in the raw material rather than stored permanently. Seaweed forests will create habitat. A couple of pictures there which would rather illustrate the point. The bottom one is Sargassum in the Sargasso Sea. And the Sargasso Sea really doesn't have any habitat anywhere, it's just a great big deep ocean until you get right to the bottom. But these mats of Sargassum are where everything hangs out, and that's what provides all the habitat in those areas. So floating seaweeds, long term, might be where we could do a lot more in the world, because there's a lot of deep ocean out there where it's going to be very difficult to put structures. And I would suggest that the industry that was to do this might be more resilient to climate change going forward. Certainly less vulnerable to drought and less vulnerable to temperature extremes, just because of the moderating effect of the ocean. As regards to the negatives, or the things that we need to question, to do anything like this we're going to need to create space and use space in coastal waters. And as you know, that's not always straightforward and it's very often contentious. So it's something that has to be faced up to from a policy point of view. If it seems seen as something that's desirable, then we have to deal with it. It's an immature technology. Compared to agriculture, we're centuries behind. Things like genetics and the whole process of mechanization, all of which means that the industry itself will be not as competitive in terms of cost of production as are more efficient agricultural industries right now. But that doesn't mean to say they can't get there. If we're going to do anything really meaningful on a global scale, we're going to have to do it in open waters off the coast, it seems to me. There's only a limited amount of near-shore sheltered water that's available on any coastline around the world, and we can't go filling all that up with with seaweed farms. So somehow we're going to have to learn to farm in open water. Now seaweeds themselves, and most of them, are quite happy in surf zones, so they can take it. It's a question of whether or not we can engineer structures to be able to do that. I've put environmental unknowns up there. There are always environmental unknowns. Shading is an obvious one if one puts these structures in the ocean. Shading of benthic habitat. But I'm quite certain there'll be others that will become known, and therefore it's just one of those things that one must be cautious of and alert to. Undeveloped markets, particularly in the West. I mean, China produces a lot of seaweed. Actually, relative to all the other food products they produce, it's not very much. But Asia accepts seaweeds and uses seaweeds in to a much greater extent than we do. So we don't use them much, and there's all that market development that's got to be done. And for that, we need to really work towards trying to maximize the value from the raw material. And I'll show you this, which is a sort of biorefinery concept. This is something that people are talking about now, not only with seaweeds, but actually with all kinds of other biological materials, where we actually take a raw material and fractionate it down into things that are of value to us. So the highest value, as far as I can see, to any of these things is to be eaten directly as food, from human food. Assuming we don't do that, one can fractionate out seaweed on the left-hand side there into the hydrocolloids. These are the seaweed's carbohydrates. These are the gums and the thickeners, and they can be used in biochemical manufacture. They can be used as gums and thickeners, and they can be used also for the production of bioenergy if that is justified by the costs. If you take the carbohydrates out of seaweeds, what you're left with is the proteins and the fats, a bunch of minerals. And of course the proteins and the fats are potentially useful. And they could be potentially useful as animal feed, and particularly as aquaculture feed. And one of the nice fits there is that aquaculture animals really don't need a lot of carbohydrate, because they don't burn a lot of energy. So it's a nice fit there to say, well, we can take the carbohydrate out of the seaweed, and what's left we use as aquaculture feed. And so, really just to sort of finish that up in terms of a global perspective, a number of us got together a couple of years ago and asked the question, so, okay, what would be the implications if we developed a global industry that worldwide and we produced 500 million metric tons dry weight of seaweed per year? What would that actually mean? Well, the first thing it would mean would be a 125 times increase on what we already produce today, which is just to show you how little really we do produce. And it would still only be 10% of what FAO tells us we're going to need by 2050 in terms of additional food. So it puts some sort of number on the scale of the problem. From a different perspective, when we look at it in comparison with corn, we produce, 325 million metric tons of corn in the US every year. So compared with the 500 million, so about the same sort of level. On a yield per acre, you'll see corn is there at 3.4 versus 8.1 for the seaweed. Much of that is because, as I said earlier, seaweed doesn't contain lignin, so we're getting full credit for all the dry weight, not just the seed. It translates into millions of acres used. There's 96 million acres of corn fields in this country. Compared to, if you just do the math, about 62 million acres. There's a lot of space. It's about the same size as Oregon, just to put it in perspective. And on a cost basis, you'll see that the current cost of producing corn is about $275 a metric ton, and the current cost of producing kelp in China is about $600 a metric ton. So that gives you some indication of how costs will need to move if we're really going to get competitive with large-scale agriculture. The actual area I talked about is less than 0.07% of the total ocean space. That's a really bit misleading. I shouldn't really put that one up, because in practice, to do any of this, we're going to have to be working near enough to land to make it practical. So it's going to be mostly coastal waters where this will go, not just above the open ocean. So it will be more of our coastal ocean space. And in terms of CO2 removal, we were talking earlier, 500 million metric tons of dry weight seaweed remove 150 million metric tons per year of CO2 from the ocean water. And according to one number I saw, that's 7.5% of the CO2 that diffuses across the ocean, air-ocean interface every year. And it would also remove 8 million metric tons of nitrogen, which is about 15% of the nitrogen that flows into the ocean every year from terrestrial runoff. So, not huge numbers in percentage terms, but maybe significant. And it would also spare a lot of land, necessarily, save land from being torn up for agriculture, because we could now use that sea space. It would spare a whole lot of fresh water, by definition, because there's no fresh water needed for production at sea. It would produce about 50 million metric tons of algal protein per year and about 10 million metric tons of algal oil. And the algal oil is the good stuff, that's rich in omega-3s and the sort of marine fatty acids that are much in demand now. It would be equivalent, or could, if you took carbohydrates out, you could produce 40 billion gallons of ethanol from it, which is about 3 times current US production. And it would employ a lot of people. FAO reckoned that the agricultural industry throughout the whole value chain uses or employs about 1 billion people worldwide. So if you just do the numbers, you can apply that to 500 million metric tons. Remember that 7.5 billion metric tons is produced worldwide by agriculture. We're talking tens of millions. Now, assuming we're more efficient today than much of agriculture is in different parts of the world, it would still be millions. So in terms of economic activity, it's something that would be a benefit. So that's really, when I sort of start with some global stuff, that really is how I see it as an opportunity that we should all be thinking about seriously. Just a couple of things now to sort of, that might be relevant locally. Sorry. There we go. This, I'm not suggesting this is feasible now, but it's not so out of sight that it might not be one day. We've thought together about ocean wind power and wave power off the west coast here. If we're going to start thinking about those things and do anything seriously, combining that with some sort of activity like this where one would grow seaweeds at the same time would make sense. And this is a project in Holland. The University of Aberdeen is doing a lot of work on this, and this is something that they've conceptualized and are trying to develop now. This is another one. This is from Ireland, oceanfuel.com. It's a good website if you want to go look at it. They've developed a system which they think will work in an open ocean environment for growing seaweeds. That map at the bottom there shows you some of the wind power sites there are around the North Sea and around Europe generally, where they think it might be possible to go and do exactly what the university people in Holland are contemplating. This is an interesting company, Bioarchitecture Lab. It actually has its origins at the University of Washington, where some guys got together and they figured out how they could fractionate seaweed and take the carbohydrates out of it, turn them into sugar, which could then be fermented into ethanol. And everyone got very excited about that. The Department of Energy got very excited about it and put some money into it, and they went off with their money and they decided, well, where are we going to go grow seaweeds in a large enough quantity to produce the ethanol that we want to produce. So they went down to Chile, where conditions are particularly good for doing it. And when they got there, they found the question that the guys back at the US Marine Biomass Program found 40 years ago. You need to produce large volumes of seaweed at very low cost to make it feasible. So they've reversed course, they've backtracked, and they've said, well, we can't produce enough at the cost we need, so we have to look at how we add value to the raw material we're producing. What's interesting is they are making a serious effort to produce large quantities of seaweed at moderate cost, and a serious effort to fractionate that down to maximize the value from it. So I think this is a company that's well worth watching, and there's a website, you can follow them, so it's something I just think that is something we should be paying attention to. This one is more likely to be feasible. In fact, right now, this is Ocean approved in Maine, who decided about 4 or 5 years ago that rather than grow mussels, they would try and grow seaweeds. They grow the kelp, the brown kelp, Saccharina latissima, and have made a go of it. They're doing well and expanding, and they've had quite a lot of decent publicity. They've got this Byline kelp virtuous vegetable, and you'll note there that the seaweed products they sell, which are sold frozen, are green, and the seaweed that's being grown live is brown. If you put a piece of brown seaweed in boiling water for 30 seconds, it will go green. And that, the chloroplasts burst, and it all goes green. It also sterilizes it, so then they can freeze it. So they've come up with quite a nice presentation, and markets are growing. Apparently at the Boston Seafood Show last week, or 2 weeks ago, and their booth was busy all the time. And just for reference, they've issued a manual, which is 100 pages of here's how to do it, everything from how to construct the farm, put it in the water, and even the nursery operations, how to actually grow the little seedling seaweeds. And then finally, this one. Most of you, I'm sure, are familiar with the Paul Allen Ocean Challenge. Well, the Puget Sound Restoration Fund has put together a project, and I don't know where it's all going to go, but basically the guts of the project is to test this idea of phytoremediation, to get to grips with some of the complications that Jennifer and Stephanie were talking about earlier this morning. Seasonal, diurnal fluctuations in the effect. Can we effectively use little plots of seaweeds to create refugia for sensitive ecosystems or not? And so that's the proposal. Let's sort of put 3 of these little 1 hectare plots into the sea and make the necessary measurements around it. And 2 other elements of that. One is the product marketing and development and marketing. Personally, I think that's vital. If we're going to look at anything like this to really make an impact on ocean acidification, it'll move an awful lot faster if we figure out a way for it to pay for itself. So rather than sort of relying on grants and goodness knows sort of acts of Congress, it seems to me if we can develop a commercial process, we're more likely to have something that's going to work. And the other thing is public engagement. As I said earlier, it's been my experience here, it's pretty difficult to put something in the water without a whole lot of protest and discussion and years of permitting. If we're going to get public acceptance for this idea that putting structures in the water to grow seaweeds is a good thing because it does has these various benefits, not the least of which is to produce food, then public engagement with something like this seems to me to be very important, and that's one of the key goals of the project. So I hope I haven't gone too far over my time, but that's what I have to say.
You're fine, John.
Okay.
We're going to probably a little bit of lunch so that we can get Q&A.
Yeah.
But you're fine.
Okay.
So, questions? Are you done?
Yeah, sure.
Great.
Yeah. Yes.
How soon does this take off as a commercial sector? Is it a couple of decades or people moving very quickly? And everything?
No, I think Ocean Approved was selling commercial products within a year. They had some help, and Sea Grant supported them, and they had some grants. They did a work with bioarchitecture labs, and they already had the mussel leases, so they had the ocean leases that they could move straight into. But yeah, as long as you've got access to some little seedling seaweeds, and the Manchester lab at NOAA here is more than capable of producing those. Put a rope in the water and start growing them. It's about sort of getting the permission to do it. Then you've got to find a market, of course. There's nothing simple, but it seems to me the market is prime. Ocean vegetables, I mean, it just seems to me we're at a time in history when that should sell.
I think you just need to get zombies to eat it, then everybody's going to.
There you go. Well, maybe. Yeah.
What does China's experience tell us about the expansion of this based on their volume of farming?
Well, that's a really interesting question. My experience in working with Asia, right from when I first started in aquaculture back in the 60s, is that there's a sort of Asian mindset to doing it, which is different from ours, and they don't think mechanically in quite the same way, they don't think automation, and actually sort of don't develop efficiencies as quickly as us. Now maybe that's a completely wrong characterization, but an example would be that when I started off, Japanese yellowtail farming was the center of gravity for all the technology in cage farming worldwide. That's where everyone went. And within 20 years, the salmon farming industry, whatever you think about the salmon farming industry, they've gone right past them. And that's because the Europeans, Norway and Scotland in particular, took a hold of it and mechanized it. So I think there's tremendous scope in China to mechanize, to go further offshore, and to generally expand the whole thing. It's not clear to me that they're really doing that yet, but it wouldn't be surprising to me that if they don't. One interesting thing I did hear the other day, a colleague from the New England Aquarium just went over there to look at it. He said that some of the nearshore coastal farms, seaweed farms in China, are now being taken out of the water in deference to tourism. So it's back to this business of using coastal waters and coastal space. If we're going to do anything out there, then necessarily we're going to be in someone's way. That's just the way it is.
What about toxins in seaweed? I understand that they can help to clean the water of toxins.
Yeah, that's an absolutely valid question. Charlie Yarish over at the University of Connecticut is using, he's been working quite a long time, what he calls bioextraction of nutrients in Long Island salmon. And if you're starting to grow things in those sorts of environments, you've obviously got to be careful. Now, I'm sure, and I don't know, I'm sure different species of seaweeds will concentrate different toxins, or not at all, as the case may be, but that's absolutely one of those questions that will need to be sort of looked at carefully. Yeah?
What was the name of the gentleman that you just mentioned? Charlie what?
Charlie Yarish, Y-A-R-R-I-S-H, University of Connecticut. He's got quite a high profile. You just put Charlie Yarish in Google, it will come up.
Thank you.
Sure.
How far offshore do the Chinese harvest seaweeds?
And they've gone quite a long way. They're off to 5-10 miles. Now that's not necessarily saying that they've got huge exposure out there. They've got some great big bays and inlets, bays and inlets, but they can go out to sea quite a long way.
Earlier in the day, we were talking about eelgrasses and that sort of thing, and to change the pH level in bays like this. Can we be in the same parallel with this algae to accomplish the same goal? For example, here.
That's a really good question, and that's the sort of thing where this Paul Allen project is sort of a start to trying to answer something like that. I don't think you're going to you're certainly not going to grow seaweeds in these places where seagrasses grow. I mean, it's just the wrong habitat. So if it's going to be anything, it's going to be a sort of defensive barrier further out to sea to stop the stuff coming in the first place. And then we get into all the ocean dynamics of currents sloshing backwards and forwards and upwelling and everything else. So how much of an effect that would have when it really gets into an estuarine situation, one doesn't know. But I'm sure it's capable of being studied, and obviously would be one of the things to look at. But I mean, it's not inconceivable to me at some point in the future that one would have a whole lot of energy facilities out there offshore, linked to a whole lot of macroalgal facilities, having some beneficial impact. I won't say it solved the problem, some beneficial impact on the amount of carbon dioxide that reaches the shore. That would be the proposition.
Well, I believe you hit the nail on the head a little bit ago when you said, if there's money to be made, this thing will grow.
Yes, that's what I think. So that's why it seems to me that that's one of the nice things about seaweeds is that potentially they're a commercial product. So
Can I just follow up on that? Also, I'm trying to see big pictures here, and one of the things that's really great about the sort of juxtaposition of the two talks that we just heard is that the restoration talk is about essentially making money because restored wetlands sequester carbon and people will pay for those carbon credits. And here, although the seaweeds may not sequester carbon long term, they can short term remove carbon and then have a whole bunch of products that are actually of economic value. So sort of different scales of carbon uptake.
Yes.
And also different ways that those activities would pay for themselves.
Yes, and they can replace fossil carbon. So but sequestration is not one of the things that they will do. Not unless we choose to sequester what comes out of it. I mean, we can always bury this stuff, but that seems to be not the right thing to do.
So, one of the things the state's going through is the process of marine spatial planning, and we hit on it earlier that, bringing in new uses could be really problematic. It's a very busy ocean. Wondering if you've looked into that at all. I mean, right now is the right time to get this on the radar.
Yeah.
It's generally made for offshore energy,
Yes.
but any aquaculture with any use.
Well, obviously, I worry about that one because it's really hard for me to see how you can marine spatially plan for an industry that doesn't exist yet. We don't even really know what it's going to look like. We can make some broad guesses. I mean, if one was going to do anything like this, we know we can do some numbers on how many acres one might actually need to use in order to remove so much CO2. I mean, I gave a global figure back there. So one could, in a sort of spatial planning context, sort of say, well, this is an industry that might develop in the future, and this is some space that we might consider how we would make it available and where. And if we're already considering energy issues, and I don't know where the wind power situation is here right now, but wave power has been in the news certainly recently. If we're starting to consider those sorts of issues, then I mean, it's just a logical thing for me to try and combine them in one area. They're still going to be in someone's way, by definition. But those are the choices that humanity makes as we increase our numbers.
Very good point. Every piece of ocean has somebody who feels it's theirs. And in some cases it has been for a very long time. In some cases it hasn't.
Well, I mean, the problem is that we've got this, it's public land, it's navigable waters. We solved the private land use issues years ago. I mean, just imagine what would have happened to American agriculture had we not had private use of land. It wouldn't have happened. So, those are issues for society. I mean, but your policy issues this afternoon, those are issues that society has to go. If we want to use the oceans more productively to produce things we need, and at the same time, hopefully, to improve ocean water quality in one way or another, we're going to have to figure out how to access the space.
There is a little data point from a Korean study that shows that, at least in their study, they're getting 10 tons per hectare out of the water, CO2, farming seaweeds.
10 tons.
Yeah.
That would be, that's possible. Seaweed's about 30% carbon. And the Chinese figure I've based all my numbers on is 20 tons dry weight per hectare per year, which would be less than 10, but it would be like 6 or 7. It's in the ballpark. And you can see claims, you read some of this stuff, people will say they can get 100 tons or 150 tons. I mean, that's not true. It's back to some of the points you were making about water moving backwards and transfer rates and everything else. You just cannot concentrate. You may be able to do it in a small area, but you will not do it on a very big area. So there has to be some space in there to make it work.
How long does it take to grow this seaweed?
Well, some of them grow very fast. The company in Maine actually grows all its seaweed in the winter, interestingly enough. We were talking about diurnal length earlier on. They actually, for temperature reasons, they grow most of the seaweed in the winter, so about 5 or 6 months. And the other thing, back to that early biomass program, one of the things they were looking at was you don't actually have to harvest the whole, well, I call it a plant, it's not a plant, you don't have to harvest the whole thing, you can mow it. Like alfalfa, you can actually take a cut out of it and then let the thing regrow. So those are the sorts of things that would be all part of the future mechanisation of the industry. There's all kinds of things that could be done.
Are there any U.S. businesses you know that are interested in investing in this?
Well, as I said, Ocean Approved in Maine is already a US business which invested, and they've recently raised new capital from US investors. I think there's quite a lot of interest in Maine, and I mean, Maine has done a really good job with its development of its aquaculture industry over the last few years. Much credit to Sebastian Bell, and he's a really good contact if he wants to follow up with it. Bioarchitecture Lab, as I said, was an American company. It's actually now owned by a venture group in Colombia, and it's operating in Chile. And there's a number of people who've expressed interest, but nothing else that I know of that's actually happening. Well, then I shouldn't say that, because then there's the hydrocolloid company. Doesn't matter anyway. There's a major hydrocolloid company that operates worldwide. They make carabine and Navar and alginates. FMC Corporation. But I don't think they do anything here specifically.
How does our water quality compare to theirs here in the Northwest?
Compared to
Connecticut? Or to Maine, excuse me.
to Maine, I would have to say better for several reasons. I mean, one, we've got a more equitable temperature regime. Two, although upwelling is causing us a variety of problems in terms of CO2, it also brings all the things that this vegetation needs to grow. It brings CO2 and nutrients to the surface. So we've got some opportunity there to grow things in it. What we don't have is probably quite the same nature of coastline. I mean, Maine's got quite a lot of sort of promontories and bays and more natural shelter, although they've got a much worse climate. Look at the winter they've had. Dreadful time like that. Yeah.
On the plus side, you talked about habitat, and I'm wondering how much we know about habitat, and I would assume it had something to do with the scale of production. But how are we thinking about that?
Well, we don't know enough. I mean, what we do know is that there's a lot of work being done on the kelp beds up and down the coast in terms of the habitat they support and then the life forms they support. So one puts some base on that, but when we go in, intervene, as human beings will do, and put structures in there and start growing a whole lot more, what will happen is to be researched. I think there are a number of people who think most of what will happen will be good things, because it will provide space for creatures and shelter for creatures, but until we prove the point, I wouldn't want to sort of say definitely.
It's been suggested that culture of sargassum would be a good fuel, and the critique of that has been based on the habitat functions of sargassum. People have said, yeah, sure, but that's spawning bed for mahi-mahi. It's the place they need. And if you wind up having large-scale creation of spawning habitat, and various pelagic fish start losing it, you've got a whole new area of management to balance. It may be manageable, I don't know. If the timing is right, and you don't wind up harvesting and ruining all these little spawners, and their new spawn.
That's a fair point. Absolutely legitimate point. And it is. I mean, sargassum, I remember sort of seeing sargassum when we come from Mexico and picking out little juvenile fish out of it. So it's exactly right. And you want to create a whole lot of artificial refuges for them. Now you've got a problem. Yes, it might be a harvesting problem, I think. Well, now you also know that we isolation. You can see that.
Yeah. Well, maybe get harvested.
Yeah.
Well, looks like it's time for lunch.
Yeah. Okay.
Thank you so much, John.
That's